Today, I'm pleased to be speaking with Dan Connor, Business Development Manager from Sunnen Products Company. Sunnen specializes in the creation, sizing, and finishing of machine surfaces, manufacturing everything from machinery and abrasives to precision bore gauges and customized coolants. Today, we'll be diving deep into Sunnen's journey in the aerospace and defense industry, exploring their innovative technologies and how Sunnen is shaping the industry's innovative future. So, Dan, Sunnen has a rich history dating back to 1924. How has the company managed to stay innovative and relevant in the aerospace industry for nearly a century? And what key strategies have contributed to its longevity?
Well, just thinking about the aerospace industry and where we are, I think a lot of it for Sunnen just has to we've had to change as the industry has. So, just in my opinion, over time, part tolerances have changed. Parts have gotten much more difficult and more challenging to hone. Just decade to decade, parts have gotten more difficult. So we've had to adapt. We've had to change to be able to meet those tolerances. So we've had to, design machines, come up with more precise tooling to be able to meet those demands, to be able to achieve them. So to me, that's probably the biggest thing as far as aerospace itself that has really changed that we've had to adapt and modify to. Regarding the longevity, in my opinion, Sunnen's really built around building quality. So we really are known for building a really quality machine, a machine that's well built and robust, that's lasted for a long time. So we've got that reputation around the machines. The same with the tooling. We've had to make high quality tooling that's precise and accurate. That meets the customer's demand. So I think that's another part of it. Our longevity is just based on that quality that we've provided. But also, I think the one thing I think that still today that we are very good about is just providing the technical help that our customers need. Being, in this honing industry for this long, I think we're able to provide, that technical expertise that they're looking for.
And the shortage of skilled machinists is a global issue. Can you elaborate on how Sunnen's computer controlled and automated processes are addressing this challenge? And what impact have you seen on productivity and quality in the aerospace manufacturing?
Okay, so as far as the skilled machinist part, just whether it's aerospace or in any industry, it is a challenge for all of us that are in manufacturing. But the one thing that Sunnen tries to do is a lot of our programming on our machines, they are a computer controlled machine, but they're more of what we call the conversational type of programming. So we're not using G code programming that you would see on most CNC machines. And the nice thing about that is in this industry where it's hard to find skilled workers, it's a little easier to train someone on that type of control. It's easier to teach them. It's easier to walk them through the process. G code programming can be just really intimidating. It can get confusing. So that's one of the nice things about it as far as, in this shortage, of skilled workers. A lot of what we do too, because of the shortage of workers, is to try to introduce automation as much as we can. We do offer custom automation that we do in house. So we add things like robots or cobots, part unloaders, part conveyor systems, to try to help minimize that operator input. So that's gotten to be over the last decade or so, in my opinion, that's gotten to be very important, very critical. And that's across all industries really, but especially in aerospace where it's really important to have the skill level that's required. In addition to the automation, something else we offer is in-process air gauging. And this allows a part to be measured and determined to be intolerance or not while it's still in the machine. So, and this not only shows the diameter variation throughout the bore that has been honed, but it displays a graphical representation on the screen. So the operator running the machine can see the diameters, but he can also see like a pictorial representation of the bore to get an idea of the shape. Is the bore small on one end or the other? So the in-process air gauging takes some of that operator requirement away. He's not having to measure the bore. The machine's doing it. It's measuring the bore in specified locations. So There's things like that that have really helped as far as to address that challenge. And as far as looking at productivity and quality, the thing is you get a lot of consistency when you take some of the operator involvement out of it. You get a lot more consistency from part to part. And then the productivity, obviously, if you have a robot controlled machine, you're taking that operator out of it altogether. The robot can run unattended. The robot doesn't take breaks, things like that. So it definitely helps the productivity.
Also, can you explain the importance of bore sizing and finishing in aerospace manufacturing and how Sunnen's technologies address the industry's high precision requirements?
So tolerances are critical in aerospace. A lot of aerospace parts, they don't run in large batches. You don't run thousands of parts at once. They're typically run in smaller lot sizes. Tolerances are very tight, very critical. In a hone bore, if you think about a hone bore, a lot of aircraft parts are hydraulic parts. So if you use that as an example, the clearance on the hone bore and the mating part that goes inside that bore is very critical. It's critical for performance of the part, but also longevity of the part. So if you think about it, the longevity of the part. So if there's a little bit of interference, if there's too much interference between the two mating parts, you get rubbing, you get wear. If it's a hydraulic part, you could get leaking between the two parts, which affects performance. Affects the longevity of the part. So that's where the tolerance, as far as size, as far as straightness, things like that, are critical for the bore. Surface finish also plays a huge part in that. And so we can adjust surface finish just by using different abrasives, different abrasive types, different abrasive sizes to try to achieve the surface finishes. Because again, the clearance between those two parts is very critical in the two surfaces. So to maximize as far as the high precision in our machines use what we call an encoder type feed system. So an encoder is used to determine diameter. So an encoder is something that can repeat on a very extremely small scale. So using an encoder type feed system on a ball screw is a very accurate way to do it. And that's the only way we're able to really repeat on size at the small tolerances that are required for aerospace parts. And then we also design a lot of custom tools and abrasives around a specific application. So when you look at a bore, just because it's the same size bore that we've honed before, we have to look at a lot of things about the bore, the material, the internal features of the bore. So the length of the bore. So we really have to design a tool, design the abrasives very around a very specific application. In doing that, it allows us not to control the size of the bore, the diameter, but also the shape. So a lot of parts in aerospace require really critical straightness, roundness, cylindricity tolerances, which requires a custom tool.
Now, Sonnen has developed the SVL automated lapping machine for high precision bore finishing in aerospace components. Would you walk us through a specific case where this technology significantly improved the customer's manufacturing process, particularly in terms of consistency, safety, and tolerance levels?
Lapping a bore, in this case, typically the SVL is really geared towards hydraulic valves. So lapping a bore has always been a very manual, labor intensive process. It's always done by hand. So the hand lapping has been the way, and it still is done today a lot of times. But it requires somebody that's got a lot of experience. You can't take someone who's very new at it. You have a part that's almost finished, and the last step is the lapping. So the part gets very expensive at this point, and it takes someone with a lot of experience because they're trying to do this by hand. So tolerances often get down to 20, 30 millionths of straightness on a bore that are 2 to 4 inches long. So the bores are fairly long, but the straightness required along the length of the bore is really tight. So the process, when it's done by hand, could take several hours to lap one part, depending on how good the operator is and how good the part is to begin with. So it could take several hours to lap a part, especially a longer valve. The machine will typically process a part. It varies again based on the incoming condition of the bore, but typically in 30 to 40 minutes, we can run a part, and that's unattended. That's without any operator intervention. The operator starts the cycle and walks away in 30 to 40 minutes compared to taking several hours. And the way this works, the SVL, it runs an automated cycle. It has an index table in there. It'll rotate the part around. It will continuously lap. It washes the part. It air gauge measures the part, and then it repeats. So to understand the way it works, so it will lap a bore. It will come around and wash that bore to clean it. It will air gauge it, and then the machine evaluates where the bore is small, where it's tight. It looks at the straightness of the bore throughout and the diameter variation, and then it adjusts how it laps the bore. So if the bore is smaller on one end, it can lap on just that end of the bore. So it runs an automated cycle to continuously adjust, and it will keep that process over and over. It goes back, it laps some more, it washes, it goes back, it air gauges. So it will continually run a 30 to 40-minute cycle back and forth to continuously improve the shape of the bore. The machine has enclosed doors, it has curtains on it, so it's all CE certified, it's protected. But again, the operator just starts the cycle, walks away, and when the machine achieves the required tolerances that are input, the cycle will end.
Thank you, Dan, for sharing your insights on Sunnen's innovation and leadership in the aerospace and defense industry. For more information on Sunnen and its product offerings, please visit www.sunnen.com.